Thank you everyone here for joining us on Lilium's Analyst Day. Welcome. I'm really pleased to be joined by our founder and CEO, our Chief Technology Officer, our Chief Program Officer, our Chief Manufacturing Officer, and our Chief Strategy Officer. I'm going to ask each of them to introduce themselves and their background at the start of their section. Last week, we announced that Honeywell will be providing our avionics and flight controls, as well as is an investor in our pipe. As Yves will explain, this is a key piece of our certification program, working with established Tier 1 aerospace suppliers. We're shortly going to fly our 5th generation demonstrator. Alistair, our CTO, will walk you through the history of our demonstrators and how this has been upgraded in our plan here. We're very pleased to announce that upon our merger, Tom Enders will become the chairman of the board of Lilium. Tom has spent 30 years in aerospace, most recently being the CEO of Airbus. He joined our advisory board at the start of this year, has already had a significant impact on the company, and we expect his impact going forward to be quite profound. We've also started our partnership, which we're very excited about, and we'll discuss further with Palantir. Palantir is helping us on the analytics connected to our flight demonstrator for faster feedback and analysis, as well as working with Dirk, our head of manufacturing, on building a control tower for our suppliers. We recently announced a transaction with Lux Aviation, which is the largest operator of private aircraft in Europe, as well as multiple airports in Germany for our vertiports, such as the Munich airport. With that, I'd like to turn it over to our founder and CEO, Daniel Wiegand.
Thanks, Jeff. Hi, everybody. I'm an aerospace engineer by training, specialized on aircraft propulsion. My 3 co-founders and me founded Lilium 6 years ago with an audacious vision in mind: to create a new mode of regional high-speed transportation that is several times faster than cars and kinder to our planet at the same time. Our first aircraft is an all-electric vertical takeoff and landing jet, but Lilium is not about a single electric aircraft. Lilium is about a technology platform and an entire ecosystem that solves the key market requirements with a 20-year horizon in mind. We will have thousands of aircraft in service around the world, fully electric, fully autonomous, and in a variety of form factors, and all of them built with differentiated technology. It's not about just getting something that flies. We believe that it's crucial for success of this vision to excel at passenger safety, low noise emissions, great customer experience, and low cost. To fulfill these priorities, we have deliberately chosen a unique electric jet technology. This technology offers 2 crucial advantages for our business goals: lower noise emissions on the one side, and scalability to larger aircraft on the other side. For example, our launch aircraft is a 7-seater jet. The winning value proposition in this market is time savings. There are some great short routes in which lots of time can be saved, for example, New York to JFK, and we can fly these short routes with our aircraft. But in most scenarios, the greatest time savings will be on regional routes. It is because of this that we have chosen to focus on a regional shuttle service, where we can achieve hours of time savings for our customers and thus fill more seats. This ultimately results in lower cost per seat mile for our service. The regional high-speed networks we are building, for example, this one in Florida, are around 100 times cheaper to build and 10 times faster to deploy than ground-based transport infrastructure like highways or high-speed trains. So we can deliver high-speed connectivity for whole regions without the need for new rail tracks or roads. Now let me tell you about the incredible aircraft that enables this model. It's an all-electric jet for sustainable operation and low operating costs. It's got 7 seats and thus offers the highest capacity in the market. It's cruising at 175 miles per hour, allowing for 5 times faster trips than a car, and it has a 5 times smaller noise footprint than its competitors. Initially, we will have a range of around 150 miles, and that enables us also to unlock regional connections. From the first day, we've also been laser focused to get safety and our customer experience right. Let me now show you a video that takes you through our team's efforts in these areas.
This physical model lets us fine-tune our serial aircraft for our partners and future passengers.
What we tried here is to give a lot of space for the legroom. The moment when you take off and you look out of our panoramic windows will be mind-blowing for you. Light brings our cabin to life. This whole fuselage is one very safe and very comfortable space for you.
The whole concept of being in a large cabin with a lot of space, very open, very airy, it'd be a great feeling.
What is really key to us is to reduce the visual noise in the cabin in a premium aesthetic.
I would say the main reason we chose ducted fans from the very beginning is noise. You have none of these noise, none of these vibrations around you, and it will just make for a much more pleasant and pleasurable ride.
In aviation, fundamental safety, but also the passenger confidence around safety are paramount. So we have incorporated highest redundancy in the aircraft to achieve safety levels similar to an airliner, but we have also focused in our technology choices on engines that produce very low vibration and don't have exposed blades. From a cargo point of view, we have the highest payload in the sector and more space, and the low exterior noise of the aircraft allows us to access urban warehouses. Thus, we can help enable same-day delivery for a bunch of companies in the parcel delivery sector. EASA, the European Aviation Safety Agency, recently conducted a study that asked people where they see challenges regarding eVTOLs in society. Obviously, we have to be leaders in all these areas, but it's been a great validation for us to see that the top 3 challenges that came out of this study perfectly align with our top priorities here at Lilium. Safety has always been our #1 priority, and low noise is a central advantage of our propulsion system, and we already invested significantly in making the necessary infrastructure available for the launch of our service. We also think decarbonization of aviation is inevitable, and it's also a central point to our own mission. Our electric jet technology lays the foundation for all kinds of electric jet aircraft in the future. Our business plan as it currently stands represents around an annual CO2 saving of 0.3 gigatons by 2030, and there's a huge growth potential beyond that. To make the Lilium vision a reality now, the most important thing is executing a real aircraft program, and thus a team that knows what it's doing. We have the former CEO of Tom Enders of Airbus serving as the chair of our board. We have the former chief engineer of the A350 engines, the former program director of the Harrier and Eurofighter jets, the former head of assembly of the A320 and A380, the man who built the world's first eVTOL, and the former SVP of quality and procurement of the A350. I'm thrilled to now hand over to this team here, who will walk you through our efforts in engineering and certification, as well as manufacturing and our plans for launch of our service. Alistair, over to you.
Thank you, Daniel. So yes, my name is Alistair McIntosh, and I joined Lilium last year as the Chief Technology Officer. Prior to this, I spent 33 years with Rolls-Royce and held a number of positions. Probably most significant was the Chief Engineer for the engines on the Airbus A350, but also the Chief Engineer for the engine's propulsion system on the Gulfstream G650. And latterly, I was also the Managing Director of Rolls-Royce Germany, facilitating a team of about 4,000 people, of which we had about 1,600 engineers. Now, to move forward, what I'd like to do is show you some footage, video footage of our demonstrators in flight. Now, what you can see is the configuration of the aircraft, the large wings at the back and the 2 canards at the front. Now, when comparing to other eVTOL configurations, typically people point to the fact that we don't have open rotors. We have ducted fans. And indeed, we have 36 in our design that we're bringing to market, positioned and integrated on the wings and the canard. Now, we have to generate a lot of thrust to get the aircraft into the air. But that thrust actually gives us great controllability. It allows us to maneuver the aircraft, and it gives a very, very stable aircraft when in flight. The ducted fans, as you can see here, for hover are in the vertical position. They will transition then to the horizontal position to bring forward thrust, forward flight of the aircraft. As that happens, as the forward speed of the aircraft picks up, the wings, the canard, and the fuselage will all generate lift. As a result, the demand for thrust to the engines significantly reduces, and as such, the demand for power from the battery systems also significantly reduces. In reality, we only need 10% of the takeoff thrust in cruise. Now, another advantage as well with having so many engines is we can design in redundancy into our system, so that adds to safety. We can make it fault tolerant. Now, as you see here, as the aircraft picks up, there's a short dip to the left. We actually simulated engine failure during the test. The controller quickly recognises this fault, rebalances the thrust, and brings the aircraft to a safe condition. All in all, the aircraft is relatively simple. The only moving parts are the ducted fans, which I talked about. There are no ailerons, there are no flaps for controlling matters. So we have no hydraulic systems, we have no oil systems, and with the stability of the aircraft, we actually have no vertical fin. Even the landing gear is actually fixed. Now, moving on from here, I'd like to focus a little bit more into our engines, our ducted electric vertical thrust, referred to as ducted fans. You can see a cross-section through the engine. Now, in my past experience, I would typically expect to see between 10 and 14 stages of compression happening. Here we have one, very simple. So we have one shaft, one group of rotor blades driven by an electric motor. Our choice of ducted fan is very simple. We want to get a very low noise signature from the aircraft. With the small diameter that we have as well, we actually are able to balance the rotor system to very smooth levels, which will not then transmit into the cabin. Inherently as well, with the duct, we're safer than an open rotor. In the unlikely event of a blade release, the duct will contain that debris. That is not the case with an open rotor. Equally, with the compact arrangement that we have, we can focus the space that we have available on a helipad to make for a larger cabin and bring in more payload, more passengers. The technology also allows us to be scalable. Now, if we focus into the cross-section of the engines themselves, what you can see here is the ducted fan on the right and the open rotor on the comparable open rotor on the left. The cross-sectional area is significantly different. Now, we have 36 ducted fans. A comparable aircraft may have 6 to 8 propellers. When we bring that to bear into the helipad, what you'll see for a standard helipad of 15 meters, about 45 feet, the one on the left shows a significant space taken up by the open rotor. Our 7-seater, for the same space, actually allows us 2 more passengers, so 50% more capacity. But also it gives us the opportunity to grow the aircraft. And as you can see on the right-hand side, we can actually grow on the same helipad up to 16-seater as a study case. So we have a future here that we can build upon. So moving on to that, I'd like to focus a little bit more on safety. Safety is at the heart of everything we do. We design to probability failures that you typically see on any other large commercial aircraft, Airbus A350, but it could be a Gulfstream, it could be a Boeing. We do this by designing in redundancy. We avoid single points of failure. And for the flight computers, for example, we can design in redundancy and use the similar systems. We can also package the batteries in a manner that we firewall them away from the cabin. We can also design in crumple zones in the event of a crash that, again, we keep the cabin and passengers safe. So what does this actually mean for our flight profile and our flight mission? We can see this in this next chart. Now, we see ourselves more as a fixed-wing aircraft and not a helicopter. Like any commercial fixed-wing aircraft, the objective is to get the aircraft as quickly and safely into the air, into the cruise altitude. And we like to do that as quickly as possible. Now, all the benefits that a ducted fan bring don't come for nothing. Certainly, during the hover phase, they consume more power than you'd expect to see on a comparable open rotor. That's actually by a factor of 2. However, when we look at a typical mission, as you can see laid out here, we spend very little time in the hover phase. In reality, for a typical mission of a 30-minute cruise segment, we only spend about 30 seconds in hover. And as the diagram shows at the bottom, the actual power consumption then drops very quickly to a low cruise level. When you look at the total mission then, it becomes clear that the difference in an open rotor with a ducted fan is that we will consume about 5% more energy for that comparable flight mission. So there's no real issue here with using the ducted fans. Now, the other key attribute that we've already talked about then is noise. Now, we've measured in our configuration that at 100 meters, we'll have a noise level of 60 decibels. A comparable open rotor configuration would have to be more than twice the distance away to achieve that same low level. And indeed, a helicopter would have to be 10 times further away at a kilometer. As we all know, this is strategically important if we want to use existing infrastructure of helipads. And with that, I'd like to close my section and maybe just be talking again about where we are in our technology demonstrator programs. The photograph you can see here on the left is our current 5-seater demonstrator. We started flying this in 2019. We'd already been flying other demonstrators since 2016. At the beginning of last year, however, we lost the aircraft due to a fire event during maintenance in the hangar. Now, it has to be said, like all good chief engineers before me, I've not unfortunately been the first to break a few engines in my time. It basically comes with the territory. You have setbacks. But it's all about how we manage them and how we respond to the issues. And what we've done here is we've set out a new energy battery system. We were already moving from cylinders to pouch cells. And I say it's something that we already had in plan. Now, as part of our flight clearance, we've also demonstrated that the modules that we've now designed can contain a thermal runaway and keep the aircraft safe. So we're now at the stage where the aircraft is actually undergoing ground testing, and will very soon be back in the air. So thank you very much. And with that, I'd like to hand over to my colleague, Yves.
Thank you, Alistair. Hello, my name is Yves EMC. I'm the Chief Program Officer at Lilium. Prior to joining Lilium 2 years ago, I spent 16 years at Airbus in various leadership roles. Most notably, I was leading quality for the A350 program during the entry into service phase and the production ramp-up. As Daniel and Alistair have already highlighted, we're aiming for our Lilium jet at achieving the same level of safety as large commercial aircraft like A350. In order to do that, we have implemented a very rigorous program development plan with very rigorous maturity gates. And from the beginning of the program of the Lilium 7-seater jet, we are designing for certification. So what does it look like? Already, a couple of important points. Before the launch of the 7-seater Lilium jet, we had already iterated several generations of demonstrator aircraft. And the intention was to validate our technology blocks around flight mechanics, flight controls, the energy system, the e-motor, the power electronics, and obviously the noise reduction. Then we have applied for a concurrent certification with both EASA and FAA. How does that work? We are in Europe. Our primary airworthiness authority is EASA, and therefore the initial type certification will be with EASA. But right after, we are enabling to achieve type certification with FAA under the provision of the bilateral aviation safety agreement between both authorities. By doing both certification, we are enabling a global market access because most national authorities would typically validate such type certifications. But also what is maybe even more important, by upfront, and that's the meaning of concurrent, simultaneously looking at the requirements of both EASA and FAA, we are designing our aircraft to meet both requirements, which is much less risky than going sequential, certifying in one location, and then taking the risk to find out that there are significant standard deviation or differences between both sets of requirements. Now, rather than me dwelling on the topic of certification, which can be a bit arduous, I will refer to a blog that we have published last week together with Bhavesh, our head of airworthiness, which really details how we approach certification for this program. So now, we are in the design phase. And what I feel very good about is we have already obtained and agreed with EASA our certification basis. We have now a CRE A01 certification review item A01, which is the equivalent of FAA G1 issue paper. So with EASA, we have agreed on the certification basis and those very specific requirements applicable to our Lilium chip. And that's very important because from now on, we talk about execution of the certification. We have removed a lot of the unknowns, and we are in the process of obtaining the same type of step with FAA. And we have, in fact, through EASA, we are working with FAA to get through this G1 issue paper. So what is coming ahead? Well, we will finish the design. We'll then get into the production at our suppliers and then eventually assemble at Lilium, ground testing, and then we'll start the flight testing campaign in order to get to the type certification. Very important point, flight testing towards type certification can only be done with conforming aircraft, type certification standard aircraft. You cannot take credit of flight hours with demonstrators for type certification. You have to have a conforming aircraft geared for type certification, which typically happens in the back end of the program. Now, as you can imagine, certification is a tremendous effort. And we are very happy in that endeavor to be able to leverage on the expertise, the experience, and the resources of our supply partners. And that's very important. Collaborating with established aerospace suppliers is a conscious strategic decision. It will give us a unique leverage for our time to market strategy because we have vast experience that we're going to tap in and resources for our certification program. And then on top of that, they have already established aerospace qualified manufacturing capacities that will be very useful for our very rapid scale up to mass production. And let's make no mistake, it's very difficult to improvise manufacturing of aerospace quality grade components. You will see later in a video more information detailing some of our exciting partnerships. But here, let me comment a few of them here on this slide. We started to select Toray as a supplier for carbon fiber composite material. Toray is a world leader in carbon fiber. And notably, they are the supplier of composite material for the Boeing 787 Dreamliner. And very early on in the program, Toray partnered with us. Then we selected Acituri for the composite structure themselves. Acituri is one of the best suppliers in Europe in that domain. And they are qualified by Airbus, by Boeing, and by Embraer. And lately, we have selected and partnered, signed an agreement with Honeywell. The fact is, we had already been collaborating with Honeywell for 18 months, and on one of the most sophisticated aspects of the aircraft, avionics and flight controls. Now, to be able to leverage the expertise of a partner like Honeywell for these very sophisticated items, which will account for a lot of the workload for certification, is something that gives us really an edge. One common theme when designing, collaborating with external suppliers, and later on, when operating a fleet of aircraft with various partners, is that it involves an enormous amount of data, technical data, production data. And to be able to aggregate this data, transform it into information, and that information transform into actionable insight, providing a competitive edge. And this is why we're extremely excited to be able to partner with Palantir. Palantir is the world leader on data analytics, and they have experience in aerospace. In fact, I had a chance to work with Palantir when I was at Airbus on the A350 program, and I know very well the value they added during the early phase of the program. At Lilium, we will emulate the unique capabilities of Palantir in various phases of the program. In the next couple of years, we're using them extensively for augmenting our capability to do the flight test results analysis. And we're also deploying them to implement a supply chain control tower to enhance our ability to manage the health and the performance of the supply chain. Down the road, we'll utilize their analytics capability to enable better predictive maintenance and improve the operational reliability of our fleet. And also, we plan to use them for flight operation optimization, battery technology strategy. First and foremost, after 2 years, our teams have been scouting and testing dozens and dozens of different cells technology. And then last year, they have found and secured access to a cell technology that will meet the unique performance of our aircraft and enable scale production, because we're not talking about very exotic technology either. So it's absolutely suitable for mass production. That's very essential. And now we are in the process of doing the certification roadmap and looking at the related testing, and of course, securing the full-scale manufacturing capacity. One important point when we look at battery cell technology, in that field of technology, it's very unique. The best keep getting better. So we have dedicated teams which are constantly looking at the market. We have hired very strong expertise in the area of sales technology to constantly look at the market and identify promising technology. And on the other hand, we are designing our aircraft to be able to be accommodating via upgrades, improved cell technology when that becomes available. And now I'd like to introduce my colleague Dirk Gebser, which is our Chief Manufacturing Officer, and which also was a colleague of mine, a good colleague of mine already at Airbus.
Yes, thank you, Yves. I joined Lilium in 2017, and with me they got 30 years of industrial experience. Today, we have 2,000 years of industrial experience after 4 years, just to give an indication of the ramp-up we are doing. I have previous experience in Rolls-Royce. My last position was a manufacturing director for all rotative parts. Then I joined Airbus in a aero structure division and had the pleasure after that to build the most amazing and complex A380 aircraft. After the A380 industrialization, I was asked to lead the A320-21 assembly in Hamburg, where I managed a rate increase from 2 aircrafts a day to 3 aircrafts a day. So first, I want to give you a picture about our manufacturing strategy. And what is important here, Lilium production is where engineering and program development teams are, to really maximize integration and contribution to a design solution. The second thing is, Lilium decided components will be manufactured by leading first-tier aerospace suppliers. Lilium will do the integration and the assembly and test on site. And that for the first prototyping and type certification phase, now till 23, where we also will get the approval of the airworthiness and will start the operations of our aerospace suppliers. The second phase is the initial production ramp up to a low volume 400 aircrafts per year. With a very lean and robust manufacturing system, we will only invest into automation where we have high repetitive processes like battery welding or assembly of engines. Here we use also turnkey providers, mostly from automotive, which gives us the experience of higher volume. That will be the next phase in 2026, where we will go global with our industrial landscape developed here in Germany. We will seek for third parties, helping the marketing entry, as well as to help the funding of our production landscape. In total, what you see here is the first 2 phases will be around 100 million. In 25, it will be about 500 people assembling systems, anti-aircraft and testing, and then growing afterwards with 1,000 aircrafts per year units globally. The first phase, as you have seen before, is the prototyping phase. Fast prototyping is embedded into Lilium's DNA. As a young company with a new product, a lot of edge technologies, we have to be very fast and robust in designing, producing, and testing in order to feed our product development plan. In last year alone, we produced 1,000 development demonstrator products and tested them. We also have the opportunity with that fast prototype facility to get mature for around about 80 core processes so that we can approve them and qualify them and the people who operate them before we start serious production. And as I said, the fast development cycles we're going through, they always end up with testing. So we're having comprehensive test capabilities with wind channel, propulsion acoustic testing, energy system environmental testing, structural and impact testing, electrical testing, and system integration labs. This is immensely important for securing the foundation and the certification for our future aircraft. And finally, why are we convinced that we will make our aircraft in high volume in 5 years' time? As Alistair mentioned, we have no fuel, no oil, no hydraulic system. We have minimum of movable parts. This is one precondition. Also, our parts count is 30 times fewer than a normal commercial aircraft. In fact, we have similar part numbers than a luxury car. And what is also important, from 2017 or 18 till we go to high volume with 1,000 aircrafts a year, we have 8 years of getting mature, of testing, and getting mature is people, systems, processes, factories, supply chain. And every year we have a very strong roadmap of really evolving and maturing. With this, I would like to hand back to Jeff.
Thank you, Dirk. A few words on my background. Prior to joining Lilium, I was the first external C-level hire at Cruise, the autonomous car company. At Cruise, I raised over $7 billion of capital, as well as worked on the first purpose-built autonomous vehicle, which is well over $1 billion program. I spent over a decade at Goldman Sachs and Morgan Stanley in a variety of capital markets and investment banking roles also. When we look at TAM, there's an emerging view that this can be the size of the light passenger vehicle mobility market. This is combined with the urgent and inevitable need to decarbonize aerospace. The pull that we're seeing from corporates, governments, and partners on the carbon side is larger than what I expected. Why are we so confident in these projections? First of all, there is a current market at $35 billion for vertical takeoff and landing. It's helicopters. This is a fundamentally better product that solves the limitations that helicopters have of being too loud, being too expensive, concerns over safety. Lilium also has the right product to access the largest segments of this TAM. We can access the cargo market. We can move passengers from New York to JFK on high volume short flights. And more importantly, we can save you hours in regional transportation. From the beginning, Lilium was set up for worldwide access. As Eve mentioned, we are unique in that we're dual certifying. This is a harder path to do both at the beginning, more work for our team. But what that does, it gives us the ability to launch in both the United States, Europe, around the world. Also, we already have an eye on China. Tencent is a significant shareholder, and we have an agreement with them. If and when we go to China, we'll be partners with access to their cloud, their payment systems, and others. Now, let me take you through our hybrid business model. We see two complementary business lines. First, a Lilium branded regional network of planes where we work with our partners. Second, turnkey enterprise sales, both in cargo and moving people, where we can sell the plane, spare parts, and our digital network for predictive maintenance and other support. Let me give you a deeper dive on how we're going to approach the Lilium network. Similar to our philosophy of working with tier one partners on the supply chain, we intend to work with the best operators, maintenance, training, infrastructure partners in the world. So for example, on the infrastructure side, in the US, we have deals with Ferrovial, Tavistock in Europe, with multiple airports. Lufthansa is providing our pilot training in Europe. And recently, we announced our transaction with Lux Aviation for Europe operations. They're the largest private airline operator in Europe. Let me do a double click now on infrastructure and our launch in Florida. Why did we pick Florida? Florida has 70 million visitors a year, wonderful weather, very welcoming politically in there. So we looked at this market with our partner Ferrovial, and we really consider them our partner. They have put over 200 million of commitments, and they will find the sites, secure the sites, construct the sites, permit the sites, and operate the sites. They're a world-class operator on infrastructure. We will repay them through landing fees when we commence site operations, and at a run rate, Florida will provide us 600 million of revenue with 125 jets in operation. Now let me take you a bit more through the numbers behind a regional network. I'm going to take you through the revenue, the pricing, and the cost side. On the revenue side, a single Lilium jet can generate $5 million of revenue in a year. There's two really important things to focus on to get to that number. Number one is the regional business model. Number two is the larger form factor. 50% more seats than competitors really pays off in the numbers. So how do we build that up? We average 25 flights a day, 60 miles. We assume 4.5 passengers out of 6 in each flight, and then $225 per mile pricing per passenger. That gets you to $15,000 a day. Take 10% downtime per year, and that's $5 million of revenue. Pricing is a key lever for us. We believe we have really conservatively priced at $225 a mile, and you can see every 25-cent increments walks you up about 7.5 points on margin. On a payback, it's 2 years, walking down 2 months for every 25 cents of additional pricing per mile. On the cost side, it's important to understand, again, spreading the cost through larger seats is critical. Almost everyone in the sector has a significant amount of cost that will be the same. Infrastructure should cost the same. Pilots should cost the same. Air traffic fees should cost the same. And frankly, many of the variable costs in terms of having to swap out batteries, maintenance spares will largely be the same also. This is also exciting if you look at one of our top 2 costs is pilots. So if you can imagine what this industry will be over 10, 20, 25-year basis, you can see what autonomy will do both for opening the industry up, but also on the cost side. Now let me take you through enterprise sales. So on enterprise sales, the interest in both cargo and logistics is quite strong. Our customers are seeing the same things that we're seeing. This is a better product at a better price point for certain use cases, and you start there. So what value do we bring? We'll provide the aircraft, the replacement parts, the software tools with a partner Palantir, and we can also provide access to our network. We can give you access to infrastructure. We can give you access to operations, as much as a future customer wants on that. We assume $4 million upfront payment, about $1 million a year in aftermarket support, immediate payback, and then lifetime profit per jet of $5 million. Now let me take you through why we like each of these businesses in projections. So please take a look at the revenue line, the people network and the turnkey enterprise solution at the top. We've assumed on volume, which is the top line, that 50% of our volume goes into the network and 50% of the volume goes into the turnkey enterprise solution. We're humble that bringing up a network, building a brand, and tuning the operations will take time. So the numbers I've presented on previous pages are the 2026 numbers, and 2024 and 2025 are more conservative. So you'll see we really lean on the turnkey enterprise solution in the early years, but then in the later years, the network effect and as the fleet grows really starts kicking in. So if you start looking at 2027, the network side becomes larger, and that trend continues. What's great about the turnkey enterprise is it gives you predictability of revenue, it gives you predictability for my colleagues to play in manufacturing, supply chain, but it has a lower ceiling on revenue. What we really like is the high ceiling of the network combined with the certainty and predictability of the turnkey enterprise solutions. Now, let me take you a little bit through the use of proceeds and the transaction. The deal that we did with Quell funds us through commercial launch. It pays for our factory in Germany and launches serial aircraft, allows Yves and his team to finish the certification process. We raised $830 million, and it's expected to close in August of 2021. A bit more on Quell and our partner and our board. So similar to our philosophy in picking partners, we think Barry and his team are wonderful partners. Barry's the former president of GM North America. He also was a CEO at Agility, a fuel company. So he and Tom have amazing experience in large multi-billion-dollar programs that will benefit us. This is combined with others in the company like Nicholas Zenstrom, who's the founder of Skype, Alex Cecili, who you'll meet in the Q&A, who's the founder of Jawbone. So really what we're trying to build is the best of German engineering, large-scale company manufacturing, and Silicon Valley leadership. That also extends to our investors and our partners. So we've spent a lot of time on our tier one suppliers, our commercial contractors. I'd like to touch on who our investors are. As you will see, many of our partners, Palantir, Honeywell, Ferrovial, Tencent, are already investors. We view these as partnerships growing an industry together. We also have great long ESG investors, Bailey Gifford, BlackRock, Tencent. Each of our investors from the private stage has committed more capital in the pipe and is going to be a long-term holder, believer in the story. I'd like to wrap up with, we believe that we have the right technology, the right certification plan, the right team, and the right regional business model coupled with turnkey enterprise sales. We are an execution story, and we believe we have the opportunity and ability to be the most disruptive player in the eVTOL sector.